In this video, we will be coding for the collision of spherical bodies. This code is same as the one we developed for line collision, same code. And for spherical bodies collision, I think this code will suffice. There's nothing new I think we have to add. Just the coordinates of the points for the sphere of a particular body. So how would we do that? Okay, let's see. So in order to get coordinates of the sphere, we're going to use a function. First of all, let's call it x1 particle 1, its coordinates, and we just have to call function of sphere in Matlab, number of n's. Okay, 24, usually 12, 24, you can refer to it, and by referring it will give x1, y1, and z1 coordinates of the sphere in meshed grid form. So we have to convert it into single column by using x1, and actually we need for particular particle the point should be along row, rows. Points of the first particle should be along rows, so we are going to go transpose of this one. Y1 is equal to y1 everything, it will be in column matrix, then go for transpose. Now this is row matrix, we need a described particle like this, so we're going to do like this only. Okay, and the same thing happens to z coordinate as well. Okay, if you have radius of the sphere 1 unit, you can actually change it later on. You can actually multiply it here and radius into this particle 1 and add this is the coordinate where we are going to put it. We're going to put it, let's say x is equal to it's 1, let's put it 2, x-axis 2. Same thing happens in here. Wait a second, radius same, put it y is equal to 10. Okay, and z is equal to also 10. This will be particle 1. The same thing will happen for particle 2. x2. Wait a second, first I should mention x2 because let's mention x2 first. x2 will be the same one, and we're gonna keep it at 10, and then rest is same. Okay, this is x y z, that's at the middle. Y z x, let's see later on. Okay, and is this m is length of you can put anyone x1 in here. Let's see how it's working for now. 625. Okay, number of this is this. Okay, total mass, let's keep higher total mass of both the particles as 100, I guess. 100. Okay, this much will work. This much is working, and mass of every particle, let's see, point is 0.16. Okay, that's because there are lots of points there. Count 100. X here, now x, there are two particles, you can write it like x1 and x2 along column. Okay, y1 and y2, z1 and z2. This much I think is working up to this point. Radius is 1, so the maximum distance between particles should be 2, I guess. Yep, distance is just 2. How many distance t? Where did I have created this? Okay, this one. 2 is the maximum one distance I'm using. Let's see how is PV looking. Run this part and go for PV. Oh my god, lots of things. Now this is the most important one. Okay, I'm going to do like this one. Velocity of the first particle is equal to ones of size x. Show me the size u1 is here, 2 into 2. It should not be 2, it should be 1. Okay, it should be 1 because it's had to go for x1 only. Now it's pretty good. u1 1625 x plus 1 because the center of mass has to be included. Now it's gonna be, you can actually have included x only. Size of along x along first dimension, second dimension. I think second dimension is the thing I need. 626, yeah, I need this one. And I'm gonna multiply it with 5 into this one, and velocity of u2 is equal to same thing, ones of x2, this time 0, x comma 2, second dimension. Now this I can write here u1, and here I can write u2. Theta doesn't matter, I think. Does it matter or does it not matter? It does matter actually. Write it theta 1, theta 2. It is in 0, 0, 0. Does it even matter? I'm just using first one. Here I'm using second one. Okay, it doesn't matter. It's of 3, x, y, and z. Center mass you can take only one because it will be moving in one direction. Cos of 0, 1. Okay, resting, I don't think I need these 3. I'm not going to change it. DCV, I need 3, that is here. Theta 1. Theta 1 is like, I've used this before. Let me run this. Wait a second. Let me see this point. This DCV. Cos of theta 1 is 0. Actually, I have done something wrong in there. It should be actually 1 comma 1 and 1 comma 1. 2 comma 1. It should be more generalized because it's doing column wise. It's not actually that much difference. DCV 100, 100. Cos of theta 0 is 1, 1, cos 90. Okay, this is working. Let me see now. How is our spherical body looking? Okay, there are 2 spherical bodies. We need to collide it. I think that code will work state. This is one body, spherical body, this is another. If you want to see one spherical body, this is your spherical body. Okay, let me run the code without doing anything. Just run it. Let's see, no error happens. Let's hope. Oh my goodness, there's some error. Okay, let me correct this error. 1 to m plus 1. What is length of m? M, let me see what is m. 625. So I have income step for this operation. xpv all rows 1 to m dtu dot product. You can't just go dot product. I can do dot product of this one, but okay, and here it's actually there DCV. Okay, I know where is error. Error is here, so I will change this one as well. Let me see how it looks like first. 1 1. So you can't just do dot product that part. It should do that. Wait a second. Let me put it here. Okay, put it here. 1 to m plus 1 is 625 ddu. What is the answer? Incompatible size. PV 626. Why is this incompatible? How many is this? There is error. Dot dot dot. I know this is but dot product it should do. View is the wrong thing. Yep, here is the thing. Here's the error. I just did. How was that? U1 is 626. Yep. X comma 2. 1 comma. 1 comma. There's an error. U1. Yep. Now it's good. It would work now. Still, it has wrong size. Okay, I didn't run this part yet. Now it's running good. Yep, it's running good. There was just small mistake I have done there. One row and number of columns would increase. Please work. Okay, goodness. Changing, moving. It will take time because rendering is slow. It's not, there are lots of points in there. And how slow that is because points are actually 626 plus 626. Now they will collide. Can I zoom now? No, I can't. Just let it deflect, collide, and deflected code is working very fine. So there was nothing else to do. Just include the coordinates of a sphere. Rest, same code we did for line. It's only because this rendering is slow. Points are very much. I can do that. This for sphere also. This surface also. I think this will encompass everything. You can go for different theta. In this theta 2, the assumption there were 3 equations and 4 unknowns. I put theta 2 in its theta, second particle theta as equivalent to the angle that the two centers make with each other. You can put it different in that state function I have already shown. Okay, this is working very good. This time taking is very. I finished and I will stop this video. I think this would be it for this video. Thank you for watching.